Hello Brain Shakers, welcome to the Brain Shakers Academy. In today's session we're going to be looking at sex determination, who then determines that the child is going to either be male or the child is going to be female. But before we go and delve into that intricate topic, it is important that we understand then the applied anatomy to that topic, because way before the 1900s there was an understanding that if a man is warmer, then the child is going to be a male, and if the female is warmer than that warmth of a man, then the child is going to end up being a female. But after the 1900s, way up after the discovery of these chromosomes and delved into more research about who determines the sex of the child, the discovery of chromosomes have then shifted the way we understand how sex is then determined. So let's quickly dive in and look at the applied anatomy and then look at what probability would then give us a male or a female child. So I have drawn a diagram here that is going to be very helpful in us understanding how then we end up with a male or a female child. So this here is an example of a chromosome, and I have deliberately drawn what a Y chromosome would basically look like, because that is where we would then have the initiation process of either male or female. So if we look at this diagram here, you notice that you have the shorter arm here. So this here is going to be a short arm, and then you have this part here which is going to be the longer arm here. Then you have the red ends here. These red ends are what we refer to as telomeres. Now, telomeres play a key role, especially in aging as well, and I'll do a separate video just to explain their role when it comes to issues related to aging. But then they also play a key role in protecting this chromosome, especially during cell replication, that the chromosome itself is not then mistaken to be the double band of DNA, because the chromosome is what houses that important element, which is the DNA or the deoxyribonucleic acid, which is responsible for passing on genetic material from the parents to the children. And in the central aspect here, you have what we then refer to as a centromere. Okay, so basically that is just holding the two sister chromatids. So you have one and you have two. So this is one chromatid and you have another chromatid. The two sister chromatids are going to be held at the kinetochore, which is just right on this region here, by this centromere that is going to be here. And within the arms or the shorter arms here, you find these bands here. Now these bands are important bands when it comes to sex determination, because these are the bands that we're going to refer to as the SRY gene. So this is going to be present on a Y chromosome, and the SRY gene is just a sex determining region Y gene on the Y chromosome. So basically that is a chromosome. And how many chromosomes then do you have? So human cell then is going to have 46 chromosomes in total. So you have 46 chromosomes, and these 46 chromosomes are then arranged in pairs, meaning that you will have 23 pairs of chromosomes. Now these 23 pairs of chromosomes, you have 1 to 22, meaning that you have 22 pairs of chromosomes. So the 22 pairs of chromosomes that you're going to have, these you will refer to them as autosomes. And then you have one pair to add to the 23 there. You have one pair that is going to be the sex chromosomes. Okay, now the 22 that you have here, which are autosomes, these are going to give you characteristics or see in a male, or you're going to see in a female, that is not related to anything to do with them being male or female, because then the sex chromosomes are the ones that are going to be responsible for making you masculine or feminine. So you have those 23 chromosomes, you have autosomes and you have sex chromosomes, and the autosomes are actually numbered from about 1 to 22 in relation to their size, with one or the first pair of chromosomes of autosomes now being the largest and then 22 being on the smallest side. Now you have a male here and then you end up having a female here. So a female will always have two X chromosomes, so you have two X X chromosomes, and a male is always going to have an X and a Y chromosome. Now, if a male gives out an X and then the female also gives out an X, then the resulting child is going to be an XX. So this automatically makes this child to be female. And if the male gives out a Y and then the female then gives out an X, this will be an XY. This then makes the child a male. And then the female gives out an X and the male again gives out an X. This gives you an XX, making then the child also female. If the male gives out a Y and the female gives out an X, then you have an XY, making then the child male. So you have one male and another male here, and you have the same one female, one female. So that gives you about 50% chance, or the probability that you would end up having a male child, and that of the female is going to be on a basis of a 50-50 ratio. So basically that is what is happening. With the male, you're going to have the XY chromosome, and with the female, you're going to have the XX chromosomes. But then what is the entire process for you to end up having a male or a female? Now I look at how sex is then determined, or who determines that sex in a separate video, and that's why I would like you to make sure that you're subscribed to the YouTube channel. And thank you so much for watching, and I will see you in the next one.